morning. It is Sunday. Good morning, 1 p.m. on Sunday. This is an opportunity for students who felt that they didn't do as well as they had hoped on the Chapter 6 assessment. So I'm going to go over detailed explanation video showing so you can prepare yourself for Wednesday's reassessment. When we multiply like terms, or when we multiply two terms, we are going to focus on their coefficients and their like bases. Remember, we can look at this as just a bunch of multiplications because this is multiplying in between these. So this is just multiplication, and we can have -3 times -5, and we can have n to the third times n to the third. We know that we treat coefficients differently than we treat bases with exponents. So coefficient times coefficient is -3 times -5. That's very basic. That gives me 15. And then when we have like bases, these have the same base. So when we multiply like bases, we can simplify, or we can make that more efficient. Is that the right word I'm looking for? We can do it in a more efficient manner by just adding their exponents, because we have 3n's multiplying itself here, 3n multiplying itself there. So that'll give us 6n's multiplying, and that's why you get 15n to the 6th. So we understand that this process, n to the third times n to the third, is n to the 3 plus 3, or n to the 6. So that's the property that we focused on quite extensively in the 3 weeks leading up to this assessment. So we should be using that. We don't have to necessarily write that. We can just understand the process and the logic behind that problem. So coefficients one way, like bases multiplying a different way. Same thing, we have coefficients. We have 7 times -2, which gives us a -14. And then we have x to the first times x to the -3rd. You don't have to move those. You can have first plus -3, which gives us -14x to the -2. Now it says in the directions only positive exponents, so we would need to move that. What is the base of that negative exponent? This negative exponent, the base is just x. The -14 is the coefficient. That's not being affected by the -2 exponent. Remember, this is -14 times x to the -2. So the only thing we have to do is move the base of the negative exponent. When we change an exponent from negative to positive, we're going to change the location. We don't write it as this. We wouldn't write it like that. That's not simplified. We want to simplify, not simplified. And we can't have negative exponents, much like we wouldn't write 15. We wouldn't have a dot in between here. That's not showing that it's simplified. That's a property that we can do. And the proper way of writing it is writing it a variable with a coefficient. So we have this as our final answer. We again have coefficients. Our coefficients are -8 and -3. We're multiplying that. That makes 24. We have not like variables, so we are not going to be able to combine these. These are going to be treated completely different because we can't combine them. X to the 0 is equal to 1. So that's really -8 times 1, which is still -8, and -8 times -3 still gives you positive 24. So we've dealt with the x to the 0. We have y to the -10th, And again, we can't have negative exponents, so this is going to equal 24 over y to the 10th. These problems were relatively simple. We were dealing with the things that we covered in the 3 weeks. Positive exponents multiplying, when we have like bases multiplying, when we have like bases dividing, when you get a positive exponent, a negative exponent, and a zero exponent. Those are the 5 components, and then the power of a power, 6 components that you were going to be assessed on. It was in the homework in 6.1, part 1. It was in the homework in section 6.1, part 2. It was in all of the work that we had done. It had gone through in the review sheets. There were videos, there were practice problems. So it kind of mystified me on why students were so, sorry, that I wonder if we can still hear, how we were so unprepared. Same thing. Now we have coefficients. We have like bases with exponents. We have like bases with exponents. So coefficients, 2 times -3 is -6. X to the 0 times x to the third is x to the third, because this is going to be a value of 1. That's a value of 1 times x to the third is just going to give you x to the third. And then we have x or y to the fourth times y to the third, which is y to the fourth plus 3. So you get -6 x to the third y to the 7th. That would be your final answer. So this first page was really a warm-up for you. And it showed. Now we've just added one more variable. We haven't changed anything that we have done up until this point. Problems 1, 2, 3, 4, and 5 are very, very similar. We're just seeing, can you deal with the negative exponents, the zero exponents, and the positive exponents? And how are you dealing with them? -7 times -3 is positive 21. X to the 5th times x to the 10th is x to the 15th. Remember, we're adding. Y to the -1, y to the 7th is y to the 6th. Z to the 3rd, z to the -10 is z to the -7. And then we just have to deal with that negative exponent. And we'll just move the z down to the denominator. And that would be my final answer. So all we're doing, and we can even break this down a little bit more, and we'll even show the steps. I'll even show it a little bit more. It's -7 times -3, x to the 5th plus 10, y to the -1 plus 7, and z to the 3 plus -10. And that'll get you the line below, and that'll produce that line, and you have to deal with the negative exponent. Number 6 has 3 terms that we're multiplying. Nothing different, so coefficient is 1, coefficient is -8, coefficient is 5. Variable x squared, there is no variable x squared in the second one. You have x squared here. You have y to the 4th, y to the 7th, y to the 2nd, and then you have z to the -10, z to the 5th. Coefficients, 1 times -8 times -5 is 40. X to the 2nd, x to the 2nd is x to the 4th. Y to the 4th, y to the 7th, y to the 2nd is y to the 13th. Z to the -10, z to the 5th is z to the -5. And we just have to deal with that negative exponent. If we change it from negative to positive, we change its location. All of these pretty much are mental math up until this point. Now we're dividing, so we went from multiplication to division. We still have to focus on coefficients. Coefficients are going to be dealt with differently than like bases. When we have the coefficients, remember how we broke it up into pieces, just like this. We are going to break this into pieces the same thing. This is 2 times b squared over 2 times b to the 5th. We can separate those. That's 2 over 2 times b to the 2nd over b to the 5th. 2 over 2 equals 1. I can't tell you how many 2's and other answers I got. That equals 1. And then we're going to simplify the b squared over b 5th. So when we deal with this, this gives me 1. And then this is b to the 2 minus 5. When we divide like bases, we subtract their exponents. And then we can't have a negative exponent. So when we change the sign, we change its location. You could do it in that manner. We can also look at another way that we can see this. We might want to think about b squared over b to the 5th. We have 2 b's multiplying itself in the numerator. We have 5 of them in the denominator. We have more in the denominator. So these 2 are going to cancel with 2 of the 5's, which leaves us with 3 in the denominator. You can just look at logically what we have there, because b to the 2nd over b to the 5th is b times b over b times b times b times b times b. That cancels to make 1. This cancels to make 1. And we notice that we have 3 b's multiplying itself in the denominator. That is the logic behind it. We again have our coefficients. I'm not turning it into a decimal. I'm not doing anything. I'm looking, is there a common factor that goes into 7 and 10? No, then I can't reduce 7/10. That fraction is going to stay as 7 over 10. Now I can deal with the variables. And when we have like bases dividing, we are going to subtract their exponents. You have 2 minus -1. The 2 is the exponent in the numerator. The minus just represents the division. And then the -1 is the denominator. So it's numerator minus denominator when we are dividing. So that gives me a to the 3rd over 7a to the 3rd over 10 is our answer. Now we can look at this in another different way. We can look at 7a to the 2nd over 10a to the -1. I think that was a starting problem. Yep. And so we can separate those. And we can have this. And look, if I want to get rid of this negative exponent, then that base is going to move up. So the a to the 1st goes to the numerator. There's going to be an a that's going to go, and if I already have 2, then logically, if I move it up there, that's going to make 3 a's multiplying itself. Another way of just logically seeing that you're moving it up. You're getting rid of that negative exponent in the denominator. If we change it to a positive, it goes to the numerator. If we already have 2 of them in there, and we put 1 more up there, that makes 7a to the 3rd. Coefficients, -3 over -3 is +1. We have m to the 7th over m to the 2nd, and we have n to the 6th over n to the 6th. -3 over -3 makes 1. M to the 7 minus 2, because we're dividing like bases, and then n to the 6 minus 6. Well, we don't even have to do that because we know n to the 6 over n to the 6 would equal 1, anything over itself. This equals 1, and this equals 1. So the only thing that we have left really is this. And that would give us m to the 5th. Very easy. We're still dealing with basic principles of exponents, which is what this assessment and this lesson was on. Coefficient, coefficient. That negative is not attached to this variable with that base. So here's the exponent, Here's the base of that exponent. It is not included with the negative because there's no parentheses. So it's coefficient of -5 and coefficient of -1, which makes +5. So if we're just dealing with the coefficients, -5 over -1, we get +5. Now if we want to deal with the variables, we have m to the first over m to the -8, which would produce m to the 9th. It's 1 minus -8, or if we were going to move this up to the numerator to make it a positive exponent, you have 1 already up there, you're adding 8 to it. So yes, of course, this is m to the 9th. And then you have n to the 9th, which doesn't have a partner, and it just stays in the denominator. That stays down there. So that is our answer. Okay? Keeping track of all the things. Coefficients are dealt differently. Coefficients are 2 and 6. Like bases, we have h to the 3rd and h to the -7. The j to the -4 and the k to the 10th don't have partners, and we may have to deal with them for different reasons. We have the coefficients 2 over 6, which is 1/3. Then we have h to the 3 minus 7, because we're dividing. We have j to the -4 in the denominator, and we have k to the 10th in the denominator. So the 1 goes away. We don't have a coefficient of 1 in front of a variable. So h to the 3 minus 7 is h to the 10th. 3, j to the -4. So we got to get rid of that negative exponent. That negative exponent would push it up. hij to the 4th. And then k to the 10th stays, that's not very good, k to the 10th would be our answer. Alphabetical order, I didn't point that out earlier. Let's go back to the early problems that we have. When we have multiple variables in our answer, not multiple variables, First one, our variables have to be in alphabetical order. Alphabetical order. So x is always going to come before y in our term. We have x, y, z. Z is in the denominator by itself, so it doesn't have an alphabetical aspect. But in the numerator, x has to come before your y. Your x has to come before your y. There's only one variable in this answer. There's only one variable in this answer. There's only one variable in this answer. M and n are in separate numerator and denominator, so alphabetical order does not come into play. Here is our next alphabetical order. H comes before j, so we have to have h to the 10th, j to the 4th. We don't have multiplication signs in there. Those are just written next to each other. We understand that there's multiplication between variables, and we don't have a multiplication in there because 3 is a coefficient. Coefficient understands that we're multiplying. This time there are no coefficients that we need to, look at that. All right, Mr. Mack almost made a mistake. We do have a coefficient. That negative is outside. And then we have the m to the -1, m to the -9th. We have p to the 0, p to the 10th. You have q to the -3, q to the 3rd. So we can do this. If we do the subtraction, because it's division, this all takes place in the numerator. M to the -1 minus -9. P to the 0 minus 10. And q to the -3 minus 3. And then we have this negative over -1. Now, m to the -1 minus 9 is m to the -1 plus 9, which is 8. We have p to the 0 minus 10, which is p to the -10. And q to the -3 minus 3, which is q to the -6 over -1. All right, now let's deal with these negatives. So I can't have a negative exponent. So I got to move those. If I change them to positive, they go in the denominator. So this answer is going to become m to the 8th over negative p to the 10th q to the 6th. That negative can be down there, it can be up next to the m, it can be outside. It doesn't matter, it just matters that there's only one of them. So the other two answers you could have had negative m to the 8th, p to the 10th, q to the 6th, or you could have had negative m to the 8th, p to the 10th, q to the 6th. No parentheses, no nothing. Once we do parentheses, we're saying that it's included with that base, which it's not. There are no parentheses, so that negative is not included. It is not part of m to the negative 9th. Number 13. Now we have powers of powers. So we do have parentheses. This exponent, what is the base of that exponent? Is the entire entity. It's all of this. So anything to the 0 is going to be equal to 1. We spent an entire day on that. You made problems, I made problems, we had examples. I submitted that on your Google Classroom math page. Google Classroom, you had examples that you made, that we made. We spent the entire day, the double period, making those, testing each other, competing against other groups. Here, we do have parentheses. So this is negative 1x to the 8th. So each of those, no, let's not use red, that gets to the 8th power, this gets to the 8th power. So this really is negative 1 to the 8th, x to the 8th. If we have 8 negatives, we know, and we talked about that, an odd number of negatives make a negative number, an even number of negatives makes a positive number. So this is going to give us positive 1, and then we're just left with x to the 8th. That would be our answer. Somebody did this. This is not necessary. This was negative x to the 8th. Somebody wrote negative x times negative x times negative x times negative x. Wrote it 8 times. Okay, it's not the most efficient, and you're telling me that you don't understand what we're learning this month, but because this is why we don't do this. This is way too time consuming, but you still have 1, 2, 3, 4, 5, 6, 7, 8 negative ones multiplying each other, which makes positive 1. And then you have x times 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 x, which makes x to the 8th. That is the wrong way to do it. Because what if I give you to the 10th or to the 20th? That's just a waste of time. It's not efficient enough. There are shortcuts. That's what we were learning. Properties of exponents. When you multiply like bases, when you divide like bases, and when you have a power of a power. That is what we're doing here. So we have 3 things here. We have a coefficient, we have a variable m to the 6th, and we have a variable n to the 0. And so we would distribute that. That is negative 1 to the 2nd, m to the 6 times 2, n to the 0 times 2. Negative 1 squared, we know is positive 1. M to the 6 times 2 is m to the 12th. N to the 0 times 2 is 0. We know that n to the 0 is equal to 1. So we're left with m to the 12th. Again, 2 to the 5th, m to the 3 times 5, n to the 5 times 5. 2 to the 5th, there are powers that we should know to the 5th at this point. That equals 32. M to the 3 times 5 is n to the 15th. N to the 5 times 5 is n to the 25. We are not going to leave our answer with those product signs. We have to write it as a simplified term. Do not write it with multiplication signs and alphabetical order. m comes before n. Now, we have -3 to the -2. You have p to the 4 times -2, q to the 3 times -2, and r to the -4 times -2. This gives me, well, we can write this as 1 over -3 squared. Notice the parentheses are still there. I just changed it from a negative exponent to a positive exponent by putting it in the denominator. The p to the negative is p to the -8. I'm just multiplying. All I did was get rid of the negative on this one. This one I'm multiplying first, so I'm just doing this product. I just did this to produce this. I'm going to multiply this. This is times q to the -6. This is in the numerators. And this is r to the +8. Only thing in the denominator right now, because I addressed this, there was no multiplication that I needed to do, like 4 times -2, 3 times -2, and 4 times -2. I just did those to simplify. They were in the numerator. They stayed in the numerator because the only operation I did was multiplying. I just simplified the exponent. All right, now I'm going to deal with those negative exponents. So I have 1 over -3 squared, which is 1 over 9. I have p to the -8. I'm going to take care of that negative exponent, putting it in the denominator. I have q to the -6. That's going to go down in the denominator. And then I have r to the 8th up in the numerator, because that can stay up there. I erased the 1 because I don't need a 1 in front of the r to the 8th. And that's how you can deal with it. Could I have dealt with the -2 first? Sure. I can absolutely do that. Let's show that one. Let's, well, not copy the page. Let's clone the page, sorry. And let's get rid of these. Let's clear the ink. So I could have distributed this -2. Oh no, I could have dealt with the -2. That's what we wanted to do, sorry. So we can deal with that negative by taking this entire, the base of that, the base of this exponent is the entirety of it because there are parentheses. So I could have written 1 over -3 p to the 4th, q to the 3rd, r to the -4 quantity squared. And then I could have distributed -3 squared, p to the 4 times 2, q to the 3 times 2, and r to the -4 times 2. That gives me -3 times -3 is 9. P to the 4th times 2 is p to the 8th. Q to the 3 times 2 is q to the 6th. And r to the -4 times 2 is r to the -8. And the only thing I need to deal with is the r to the -8th because I can't have a negative exponent in my final answer. So that would need to move, and that would go up to the top. And I get r to the 8th over 9 p to the 8th q to the 6th. Same exact answer. I just dealt with the negative earlier than later. So same answer. We have the quantity of -2 to the 3rd, m to the -2 times 3, n to the 3 times 3, and p to the 3 times 3. -2 to the 3rd, we have an odd number of negatives, so I know my answer is going to be negative. And it is not 2 times 3, it's 2 times 2 times 2, which is 8. We have m to the -6th, n to the 9th, p to the 9th. I need to get rid of that negative exponent, not negative coefficient. I saw a lot of people move this down because they thought it had, we only move negative exponents, not negative coefficients. Nothing wrong. There's nothing wrong with a negative coefficient. That stays wherever it is. And in this case, it's in the numerator, -8. N to the 9th, p to the 9th can stay up here. The only thing I'm moving is m to the 6th because it has a negative exponent. let's go back. There were a couple negative coefficients early that people moved. No, not that. Yes, a lot of people. A lot of people did this wrong answer also. Let's look at this one. They had negative 14. They wrote 1 over 14x to the second. That is wrong. That's a negative coefficient, not a negative exponent. Changing the sign of a coefficient does not change its location. Negative 14 doesn't become 14 in the denominator. Under no circumstances does negative 14 equal 1 over 14. Does not make sense. That doesn't make sense. A negative exponent equals 1 over x. That makes sense. Yes. That makes sense. That is telling me that I have an excess of x to the first in the denominator. It is just representing terms and exponents in the denominator, in the numerator. It's a way of writing the base in the numerator, and you would have a negative exponent. So work on this, hopefully. People who are looking to improve their score. Oh, extra problems. Yeah, you can even try a couple extra problems. Let's look at those coefficients. Coefficient, coefficient, coefficient. You might want to pause the video, try these, see if you get them right. So I'll give you a second, pause it, do this problem out, and then I will complete it. Okay, welcome back. You have negative 1 times negative 1 over negative 2, which produces a positive, no, negative. We have 3 negatives make a negative. You have negative, and then 2 is in the denominator. So we'll do that. Now, let's deal with alphabetical. I'm going to go alphabetical first. I don't have an x in that first term. I have x to the second. So that has no pairing. So x to the second is just going to be there. Let's deal with the y's now. So I have y to the fourth, y to the third, y to the fourth. Well, those y to the fourths in the numerator and the denominator are going to cancel each other, and I'm just going to be left with y to the third in the numerator. So that's y to the third. And now let's deal with the z's. We have z to the negative 3 and z to the third. So if I move this down, I have a z to the third in the denominator. Oh, and I almost forgot that z. That one's kind of tricky. That wouldn't have been very good. So I have z to the fourth in the denominator and z to the third in the numerator. So I have an extra z in the denominator. So that would be my answer. Yep. Okay. That would be your answer. That negative can be in the numerator or denominator. It doesn't matter. But that would be my final answer. So take a peek at this one. Pause the video. Take a second. Do this problem. And then turn it back on and we'll go over the answer. Welcome back. Hi there. Yep. Coefficients, negative 3 and 3, which makes negative 1. And then we have our x's. Let's look at, we have x to the fourth, x to the negative third, x to the 0. So this x to the negative third goes down. X to the 0 is equal to 1, so we have an extra x in the numerator. We have 4 in the numerator, 3 in the denominator, so I have an extra x in the numerator. Let's do my y's. I only have a y to the fourth, and it's positive, so that's fine. So that stays in the denominator. And now let's deal with our z's. We have z to the fourth, z to the fourth, z to the third. That's z to the eighth in the numerator, z to the third in the denominator. So we're going to have 5 left over in the numerator. And that would be my answer. Again, that negative can be in front of the x, it can be outside, it can be in the denominator, but there's only one negative. Let's do 3. Ooh, okay, now we got a little technical stuff. So we have an exponent here that we need to deal with first. we can't multiply or cross cancel anything. We have to deal with that. So we can move that up to the top or we can distribute it. I'm going to move it to the top. I'm going to try to keep it negative p to the third times r squared times this quantity p to the third q squared. R to the 0, we don't need to do that. That's equal to 1 over to the second power over negative p. I'm not dealing with the coefficients yet because I have to deal with exponents. Coefficients would be dividing, and I have to do exponents before division. So I'm going to distribute this out to each of the terms. And so we have negative 2p to the third, r to the second. That's p to the 3 times 2, q to the 2 times 2 over negative p. So I have negative 2p to the third, r second times p to the 3 times 2 is p to the 6th. Q to the 2 times 2 is q to the 4th, all over negative p. Now I'm going to deal with it. This looks like our starting problems on the assessment. We have coefficients. Negative 2 over negative 1 produces positive 2 in the numerator. We have p to the third, p, and p to the 6th. So that's going to leave me with p to the 8th in the numerator. And then we have r squared, and we have q to the 4th. So those LMNOP R. So alphabetical order, I'm going to put that q to the 4th and then r to the 2nd. And that would be my answer. Alphabetical order, that's a really good one. Did you take the time to remember that you have to be in alphabetical order? And the last one, we've got two exponents we have to deal with first. We got to deal with this term, and then we have to deal with this term. So I'll let you do this, pause it, and then restart it when you are ready, and we'll go over the answer. All right, so welcome back. I have negative, I have 2. I'm going to put this in alphabetical order right now, just so I know where my things are. I'm going to distribute this into each of those. So that is negative 2 to the third, and that is z to the negative 2 times 3. That's the yellow part. And then we have 2 to the 4th, x to the 4th, and y to the 4 times 4. It's a lot of stuff. So numerator is 2x to the third, y to the 4th, z over negative 2 to the third. So negative 2 to the third is negative 8. We have z to the negative 6. And then we have 2 to the 4th, which is 16, x to the 4th, and then we have y to the 16th. Okay. Now, do I want to keep? Yeah, let's, nope, I'm going to cancel. I have my coefficients. I have 2 over negative 8 times 16. That 2 does not cancel both of those denominators. It's as if we saw, and that's a common mistake students will do. They will cancel the 2 with the negative 8 and the 2 with the 16. Well, if we have 2 over negative 8 times 16, that 2 cancels with that, and then it's gone. So it only cancels once, can't cancel twice. That 2, there's only one 2, and it's multiplication. So you would have 1 over negative 4 times 16, which is, what's that, 64? Yeah, negative 64. So you're going to get, in the denominator, negative 64. Let's deal with the variables now. Like variables, x to the third. Oh, that's not an x, Mr. Mack. And x to the 4th in the denominator. That's a leftover x in the denominator. Let's deal with the y's. We have y to the 4th, y to the 16th. So the numerator, the 4 in the numerator, are going to cancel with 4 to the 16 in the denominator, which leaves me with y to the 12th. And now we have z's, my z's. So this z is going to go up to join this one. And so that'll leave me with z to the 7th in the numerator. And I think I dealt with everything. And lots of things to deal with, so I would definitely check my work. But those are your extra problems. So hopefully you'll find some time this weekend. Tomorrow, Monday, is your day off. Take some time and work and get prepared for that reassessment on Wednesday in order to take advantage of the reassessment. Congrats, good luck. Let me know if you have questions.